I'm going to try really hard to get this one done, but I'm almost running out of time. So we've already talked again about rational exponents, okay, and how you can combine those and things like that, and how these just follow the same rules of exponents. So I know when I multiply two things together that I'm just going to add my exponents. So that's what I'm going to do here. 4/5 plus 6/5, I could just add the tops. That's x to the 10/5 or x squared. Okay. I know when I have a power to a power, I'm just going to multiply my exponents. And I know when I multiply fractions, I just multiply the top two numbers together and the bottom two numbers together. And then if I can reduce it, I reduce. 1/2, y to the 1/2 is my answer. Okay, so I can do the same thing here. I'm going to have to, again, add these exponents, but I can't add 4/5 exactly to 7/10 without finding common denominators. So I could easily turn this into a tenth by multiplying the top and bottom by 2. That's 8/10. So 8/10 plus 7/10 is going to be p to the 15/10. Again, that can reduce to p to the 3/2. Again, power to a power, multiply. So that's m to the 6 times 2 is 12. 5 times 5 is 25. That one does not simplify any further. Okay. If I'm going to add these, 3/8 plus 4/3, well, I may have to go way back to common denominators and all that kind of stuff. A good one between 8 and 3 is really 24 is as good as it gets. Okay. So this one is 9 over 24. This one is 32 over 24. When I add those, 9 plus 32 is 41 over 24, x to the that power, and it does not get any simpler than that. I know that's unfortunate, but you know, we do the best we can. I know how much y'all love fractions, so I'm just pointing out how fabulous they are. Same thing here, you're going to multiply those together. So s to the 4 over 18, that does reduce a little bit by 2, 2 to the 9th, okay? Now something else you can do, if you don't like reducing from here, you can always check at the beginning to see if you can reduce anything on the diagonal. Okay, for example, I could say 6 goes into 4, that reduces to be 3/2, and then just multiply that straight across, and notice you would get the 2/9. Okay, so a little bit up to you on that. Ooh, this is a good one. Remember, when you divide, you subtract your exponents. Okay, so up here you have to remember that this is an understood 1. So you're going to do 1 minus 1/3. Well, 1 is the same thing as 3/3. So 3/3 minus 1/3, p to the 2/3. Okay. Before you can do this next one, again, you're going to have to find common denominators. A good one between 1/2 and 1/3 is to turn them both into sixths. So this is x to the 3/6 and x to the 2/6. And when I subtract 3/6 minus 2/6, that's x to the 1/6. Okay. So on this next one, we kind of switch gears just a tiny, tiny bit. Okay. For example, 128. If you factor treat that out, that is going to be 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. Okay, so 128 is actually, I have 1, 2, 3, 4, 5, 6, 7 2's. So I can rewrite that as the 6th root of 2 to the 7th power. Okay, or, because we're using these rational exponents, I could say that's 2 to the 7/6. And to me that does look just a tiny bit nicer than this right here. Okay, so the same thing here. 49 is actually 7 times 7, so you know that that's 7 squared. So again, I could say that's the 4th root of 7 squared, or I could say that that's 7 to the 2/4 power, or even better, I could say that's 7 to the 1/2 power. Okay, let's see how I reduce that. Okay, 288 is actually 2 times 144, which is 12 times 12, which is 2 times 6, which is 2 times 6, which is 2 times 3, and 2 times 3, right? So if I simplify this, then I have all of these 2's, 1, 2, 3, 4, 5, so the 2's can come outside. Inside, I'm going to be left with a 3 squared. Okay. Again, you could leave it like this. This would be a perfectly acceptable answer, quite honestly. Or if you prefer, you could say that it's 2 times 3 to the 2/5 power. Either one of those I would say is quite acceptable. Okay. Square root of 32. 32 is 16 times 2, so that's just 4 square roots of 2, times square root of 16 is 4. 4 times 3 is 12. So you know how to do this one. This is just 48 square roots of 2. Would probably be the easiest way to do it. There are a couple other things you could do there, but I would say that's simplified enough. Okay. All right, what about this one? 25, you know, is 5 times 5. So this is the same thing as 5 to the 2/3 power, times, this is 5 times 5 times 5. Okay, so 5 to the 3/2 power. Okay, so I could just add those exponents. Okay, so you can treat numbers a lot like you can treat these letters, and sometimes it's a little simpler. So again, I would have to turn those both into sixths. This would be 4/6. This would be 9/6. Again, I could add those. 4/6 plus 9/6 would be 5 to the 13/6. Now, is that more simplified? You know, it depends on who you ask. 16 is 4 times 4. 2 times 2 times 2 times 2. So again, I could say that's 2 to the 4/6 power, or just 2 to the 2/3 power. Okay, so that is definitely a little more simplified. Okay, this last one, ugh, how gross is this question? And so let's simplify it just a little bit. Okay, so I'm going to look at each letter individually. Okay, so on top, I have an A and a square root of A. So that's the same thing as A divided by a to the first divided by a to the 1/2. Okay, again, first is just 2 over 2, so this is just a to the 1/2 power. Okay, so that's simplifying my a's. Now check out the b's. On the top, I have b to the 4/3, right? On bottom, I have b to the 3/2. Okay, again, I need to subtract those, so I'm going to turn those both into sixths. So 4/3 is 8/6. 3/2 is 9/6 when I subtract those. Okay, that is b to the negative 1/6. Okay, and I could write that a to the 1/2, b to the negative 1/6, even though it would be more simplified to say a to the 1/2 divided by b to the 1/6. Okay, so there's some crazy stuff here.